Okay, good afternoon. My name is Antonio Sala, and I will talk to you about my research project, which is titled Information Integration for Biological Data Sources. I'm a PhD student in Computer Engineering and Science of the 22nd cycle, and my tutor is Professor Sonia Bergamaschi, and my co-tutor is Professor Maurizio Vincini. So, which are the main problems and challenges of this topic? The main problem is that in the last few years, a large amount of biological data became available, and many databases have been published and are available on the web, and so there is a huge availability of data for biologists and researchers in biology. And they are experiencing troubles querying these data sources because these data sources are usually offer incomplete information, and sometimes, just sometimes, they are partially overlapping. Another problem is that the users are usually biologists, and they have really limited information technology skills, and many times they don't even know what they are really looking for. So, during my first year, we started experimenting the MOMI system developed by the database group of our university within the Serial project, which is a research project conducted by the agrarian faculty of our university. The aim of this experimentation of this test was to perform intelligent data integration of existing databases, and in order to create a global virtual schema that we call a GVV, that could allow the genotypic selection of cereal cultivars. That means to extract the molecular data that are correlated to phenotypic traits. And this is said the molecular data that express a particular phenotypic trait. The data sources we integrated are two existing and very famous molecular databases. They are American. They are Green Genes and Gramine. A relational database built with the data obtained by the Serial Research Project. The Germplasm Resource Information Network, which is an American repository of phenotypic data about American cultivars, and other data obtained regarding Italian cultivars, of Italian cereal cultivars. So the methodologies applied was to translate, to extract and translate the schema of these data sources in a common language, that is ODLI3, exploited by the MOMI system for the integration purpose, and in order to create a global schema that the user can query through a single interface. Here is a brief overview of the integration process, which starts with the wrapping phase, which is indeed the translation of the data source, of the schema of the data sources in the common language. And these schemas are then semi-automatically annotated according, in our case, with an extended version of, a manually extended version of WordNet. Then the framework creates a common thesaurus exploiting the annotation with WordNet to extract lexicon-derived relationships. Then the framework extracts from the schema other relationships. Other relations are inferred or can be supplied by the user, and this common thesaurus is used then to cluster together the semantically related elements of the local sources into classes, cluster that we call global classes. Then mapping tables are created to store the mappings between the global classes with the local elements, with the local classes, and the global schema obtained is then again semi-automatically annotated and can be exported in OWL for compatibility reasons. So the schema we obtained in this application can be seen as an ontology of the local sources, and these ontologies turned out to be really useful for the biologist, because for the researcher of the Serial project, because it allows to correlate the molecular data coming from Gramini and green genes and the serial project itself, with phenotypic data of the green database and other data collected by the serial project. The ontology is in fact divided into two parts, one regarding genotypic data and the other one regarding phenotypic data. And these two parts are correlated and thus allowing to perform genotypic selection on serial cultivars. And this is the first experience of the first knowledge base that can provide this kind of information. And this is now publicly available on the website of the project. And this is the first Italian database that combines, as I said, molecular and phenotypic data about cereals. We also developed a very simple graphical interface to help the users which have really low information technology skills to query this knowledge base, and just pointing and clicking the concept they are interested in. Another activity I carried out during my first year was devoted to try to study and try to integrate data and services. And this was carried out in the context of the NEP4B research project, which stands for Networked Peers for Business, whose aim is to integrate the knowledge provided by data and services in a peer-to-peer environment, and also in this case, exploiting the MOMIS system as integration framework. So I studied the web service modeling language in order to understand if it was possible to its translation into the ODLA3 language that is used by the MOMIS system. And after this study, we proposed an approach for describing a unified view of data and services to provide to the user a complete knowledge in terms of data and services of a specific domain. And this approach is not alternative to the existing techniques developed by the different communities that are studying data integration and service discovery, but works in conjunction with them by improving the user knowledge. So these are my publications, and I concluded.